Good morning, afternoon, evening to our one listener out there. My name is Luis Hernandez, and we will be covering our NAE project in today's podcast. As you know, much of the world turns to fossil fuels for core energy utilization, which has dramatically affected the entire globe in more harmful ways than good. Climate change is accelerating rapidly, mainly due to our excessive use of these dirty fuels, and at our current rate, we may have to face some of our biggest global and environmental challenges in the next few decades. I preface the main topic of our podcast with this to help explain why we chose what we chose for our NAE topic, which was making solar energy more economical. Knowing the catastrophic outcomes of what using non-renewable energy can yield, we searched for an alternative. That alternative is solar energy. Solar energy is a nearly inexhaustible resource due to the everlasting presence of our sun. It is a much more environmentally friendly way of obtaining the energy we need because no air or water pollution is given off during the energy production. Since our goal was to make using said energy more economical, we pulled data from an energy census and economic data from 2010 to 2014 in the United States, which gave us a realistic idea of how financially effective solar energy can be. The program works in a way that calculates the average uses of electricity in multiple states and multiplying it by a specific market value. The data sheet was made for collecting data for revenue up to 25 years. The reason why we chose 25 years is because our data sheet gave us a 25-year period of profitability and an ideal expectation of the total revenue to satisfy a quota. Our project is a collection of code incorporating all of our goals and ideas in order to achieve making solar energy more economically sound to invest and trust in as a renewable resource. I'm going to hand this over to Zahid, who is going to cover algorithm and code logic.
All right, so this is for algorithm and logic. The goal of our code is to have two Excel files inputted. One's going to be states and the usage. So the first column is going to have the states, and then the rest of the columns will have the usage for a certain year. The second Excel file will have facility costs, so how much it's going to cost to operate that facility for every year, and also how much it's going to cost to build that facility. So we output a menu that has all of the states that have been inputted, and then unless they select the state and just keep on clicking X, it's just going to keep on showing the menu for the states. Once they do select the state for that state, it's going to calculate average energy used. We do that by just finding the mean of a row for a state, and then we find the yearly revenue. We find the yearly revenue by multiplying the years by the average energy used, which we just calculated, and then multiplying that number by the average energy cost. After we do that, we find the total cost of building the facility. So we find that by summing all the years and how much it's going to cost to operate through those years, and then also how much it's going to cost to build the facility. We find the facility count by dividing the average energy used by the how much on average a solar farm will produce, how much electricity a solar farm will produce, and then we just round out to the highest number. We find the total facility cost by multiplying the facility count by the total cost. So this will tell us how much it's going to cost to build all the solar farms to cover a state's needs. Once we find that number, we're able to calculate money made. So we just find the yearly revenue through, as I explained earlier, average energy use through the years, and then subtracting that by the total expense. And then we just graph this out. And then once on the graph, it'll be red until they start making a profit. Once they do start making a profit, it'll turn green. But they need to make that profit within 18 years. If they don't make it within 18 years, going to be outputted as not profitable, and the entire graph will stay red and there will be no green line on
Thanks, Saeed. My name is Blake, man, and I'm going to be running the code through right now and kind of explaining how the processes work and how we kind of set it up so that we could get the data we needed. So we have our original test case, which we got from our data sheets, that was just an average of usage in BTUs, which we then converted into kilowatts. So when you run our code, and you'll get a menu that pops up, and the menu will basically ask you what state you'd like to run the calculations for. So when you click on the state here, it'll show you as the profit line margin is taking place. For the specific state that I chose, Arizona, it outputs 3 solar energy plants that are needed, and that it'll be profitable within 16 years. So essentially, this this program is developed here to essentially just allow the user to know how many years until they can expect profits, how many solar plants they need, and then a little bit later we're going to go into more details about how the plot is working and how it generates a graph to show profitability. We do some other test cases. So we, for instance, add in a second set of data, which puts the production average to be half, essentially, of all of what we had originally, which makes that value really, really low. What we end up getting is that no state is profitable for solar energy, which, in a sense would be completely outrageous, because it just means that the amount of production of electricity that's being used, it would not be enough to have a solar energy plant installed in those specific states. So if you run this program again with the lower data for the usage, any state you click on, it's going to display that it's not profitable for the state to switch over to solar energy, because we have it set to the parameters of being 18 years to make profitability. And then when you see the plot, so the revenue plot for the state of Nevada, it shows to be at like 19 years. And of course we set the program up that if it wasn't making it to 18, then it would not be beneficial to the state. All right, right now I'm going to go ahead and switch it over to Thomas. He's going to talk a little bit more about the project. Thank you.
Thank you. This is Thomas Howard, and I'll be covering the limitations of the project. As a team, we had many ideas that we wanted to implement into the final project. However, with the different schedules, it did make the process difficult. So some of the things that we would like to add that we were unable were things such as if a state does not meet the requirements for profit timeline that was based off the data sheet provided for a single plant, then the program would display information about how to make that specific state more profitable by either cutting down market price, plant production, or by increasing usage. We did have in the code a feature that shows if the plant would be profitable within a certain time period. With the sample data we used, an ideal plant would need to be productive within 18 years. It then gives 7 more years to gauge the revenue. The user can only get specific data to display by selecting the state. We would like to have a setting where we could plot various states at the same time, or even to automatically create a table to display on the command screen. Some of the limitations that we were faced with were finding data to support the project. In the program itself, we would have liked to made it all user input, then run the calculations to display information. Whereas now the only way to get the information is to load in the data and run the program individually. Although we were unable to put everything in our program, we were still able to make a very well-rounded product. And on to Harris with applications.
Thanks, Thomas. This is Horace, and I will be covering the transition line depicting profit and the applications of our program. We incorporated a green and red transition line in our program to demonstrate where the state breaks even in the start and starts collecting profit. The red line illustrates till what time the state is debt-free. The green line is just a continuation of that line and shows from that break-even point how the state is just going to purely profit. The timeline is 25 years, and within that, if the state does not reach a profit point within 18 years, then they won't benefit from making the switch to solar energy. This scenario has a rare chance of becoming true due to the fact that most states easily break even on production costs within that given time frame for solar energy. Our transition line was incorporated to illustrate when and just how profitable solar energy can be. Our program was designed to have numerous applications. Such applications include calculating state energy revenue, a state estimating cost to switch to solar energy, calculating percent margin profit over a 25-year period, years estimated till breaking even on a solar construction debt. And finally, when a state energy department wants to know how many solar facilities they need to construct, they can utilize our program. That's all from me now. On to Imad.
Thank you, Horace. For future improvements to our code, we would like to give methods to users on how to cut 10, 20, or 30% of the cost in a solar energy facility if the chosen state does not meet the required revenue to support the plant. We are also considering adding a feature to allow a user to input the cost of plant maintenance and the cost to produce the energy in the first place, instead of using predetermined values for the cost. This will allow for the results to be more specific for a user scenario. It would be better if more data was available for energy usages in each state, because this would allow the results from our code to be more accurate. We would like to make it more interactive for the user, outputting more information that would better help the cause of providing solar energy to the general public, adding things like more user variables, breaking down the production into more sections, and displaying more information that gives the user a better understanding as to why the state would or would not be productive. Displaying more information to the user about cost cutting and profit. This information is important to the project issue at hand and why we would really like to add these features to future implementations. As a recap, we chose making solar energy more economical by showing which states would benefit most from the introduction of solar power plants, ran through how the code worked, converted the original plans we had for the project, discussed the problems we encountered and how we overcame them, explained the meaning of the break-even line and what it meant when changed colors, and described our future plans for the project. Thanks for tuning in.